Hello everyone, Dr. Turner here. This video is intended to give you an example of the kind of short video I'd like to see you do for your lesson in this class. Also, it's intended to show you an example that is not in English language arts, because I realize I give you a lot of those because that's my background. But Libby Sykora has very generously donated her materials so I can walk you through her materials and in the sort of way I'd like you to walk us through your materials. Her lesson was called The Underlying Theorem of Catherine Predictability. And when we came in, her learning outcome was, as a result of this lesson, I will be able to interpret a mathematical model and write a summary that articulates what the model represents. So she introduces us to a novel called An Abundance of Catherines by John Green. And in the novel, the protagonist named Colin finds that he only falls in love with girls named Catherine and that he's always dumped by girls named Catherine. So Colin starts to come up with a theorem that will predict whether he or not he's going to be dumped and how long it will take if he does. He starts with a bell curve thinking about big time dumpers and less big time dumpers. And he tries to think about what that would look like in numbers. And he thinks to himself, well, what are the variables in relationships? Before Libby showed us what Colin comes up with, she asked us to generate what we thought variables were in a dumper-dumpy relationship. And once we came up with those, she showed what Colin comes up with in the book, which is age, popularity, attractiveness, dumper-dumpy, introvert, extrovert. She continues to read the book in which Colin realizes that one of these might be more important than the other. Like maybe he should square the attractiveness differential. Maybe that's more than age, more than popularity. Which one's the most important and how do you represent that with numbers? She shows us what Colin comes up with finally with all the different differentials and how they work in the equation. She shows us how if you use that equation with actual couples, that it actually does seem to predict how long their relationship is. And she explained how, depending on that shape of that graph, depends on who dumps who. She does another couple of examples for us: Brad Pitt and Angelina Jolie, Christina Yang and Meredith Grey. And then she had modules all set up on Desmos for us. Our job was to pick a random couple, model their relationship with mathematics, and come up with an explanation. At no point in our groups were we unsure what to do. We knew exactly what to do. And this is also an example of differentiation because we could take as long as we needed to on a slide. We could move ahead if we needed to. So it made it really easy to follow and take at our own pace. So step one was choosing who was going to do what in the group. Step two was to go to the random celebrity generator and pick one person from the first page that popped up and one person from the second page that popped up. And then she had us run them through the theorem. So the first one was the age differential. So we were actually doing this math. Then we calculated the popularity differential. And one of the interesting things this taught was not just numeracy, like how we were plugging information into this mathematical theorem. It was also teaching us the arbitrariness of numbers when we assign numbers to things. What's the difference between a 4 and a 5 on the attractiveness differential? So we had some really interesting conversations about what that means. And then we went to the dumper-dumpy differential. We went to the introvert-extrovert differential. And finally, once we had all of our numbers, then she had us go right into Desmos, which already had this equation keyed into it. So all we had to do was put in our information, and we could actually watch the relationship in action as we started to put in our information. At last, we had to explain in writing, here's her writing piece and her assessment piece, what our model represented. And so by doing so, we were able to accomplish this goal that she had in mind for us. As a result of this lesson, I will be able to interpret a mathematical model and write a summary that articulates what the model represents. So I hope I kept that under 5 minutes since I'm asking you to do the same. And I hope you won't hesitate to take risks on this one. I'd love to see you try something new if you're feeling up to it. And ask me all the questions you like. I am looking forward to seeing your lessons.